When I think of a time machine, a variety of ideas come to mind. Some might want to travel back in time to visit ancestors or experience history firsthand, while others might be more interested in the future, seeing how humanity evolves. The concept sounds fantastical, but maybe it's not entirely out of reach. Although no time machines exist today, researchers are exploring ways to make this dream a reality. I want to share some insights into the current theories surrounding time travel, and perhaps one day, someone among us will contribute something groundbreaking. What seems like pure fiction today might become reality tomorrow. There are three main hypotheses for time travel. The first is derived from Albert Einstein's theory of relativity. According to this theory, time travel to the future could be possible by traveling at the speed of light. This is because time slows down for an object moving at high speeds relative to a stationary observer. For example, if someone were to travel at the speed of light, they could circumnavigate the Earth 10 times in 1 second. Meanwhile, someone standing still would experience 3 seconds passing. On a larger scale, if you traveled at the speed of light to Alpha Centauri, returning after what felt like 6 years to you, I would have aged 10 years on Earth. When you returned, everything would have changed. Technologies would have advanced, your children would have grown up, and the world would be a very different place. But you would still be young, having taken a huge leap into the future. The second hypothesis involves long-term freezing. This idea suggests that a person could be frozen for an extended period and then revived at some point in the future. However, human bodies don't survive freezing as easily as cold-blooded animals do, and scientists have yet to figure out how to make this possible. So, freezing ourselves for future travel is still off the table for now. The third hypothesis focuses on advances in quantum physics. If we can master quantum mechanics, we might eventually learn how to teleport information or even physical objects. However, this is a far-reaching concept that remains beyond the scope of current scientific understanding, leaving it as something for future generations to explore. Of these hypotheses, the first, time travel through light-speed travel, seems the most plausible. The famous physicist Stephen Hawking spent years exploring the link between time and space, even speculating about the possibility of time travel in his writings. In his final book, published in 2018, Hawking concluded that time travel might be achievable in theory. To understand the scale, the speed of light is approximately 299,792,458 meters per second, or about 670,616,629 miles per hour in a vacuum. In air, it's slightly slower, but the difference is negligible for our purposes. The fastest man-made object to date is the Parker Solar Probe, which currently travels at about 393,000 kilometers per hour. In 2025, it's expected to reach speeds of up to 692,000 kilometers per hour. While impressive, this is still only about 0.06% of the speed of light, far from sufficient for time travel. To achieve even 1% of the speed of light, we would need to combine the power of 16 Parker Solar Probes working in sync. To reach the speed of light, we'd need 1,600 such devices. The cost of such a project would be astronomical, an estimated $1.5 billion for one probe and $2.4 trillion for 1,600 probes. Additionally, no one knows how such a device would behave, and the vast amount of fuel required for such speeds is impractical. Plan B, according to Hawking, involves bending space-time to create a wormhole, a theoretical tunnel through space and time. This would allow travel to both the past and the future. To visualize this, imagine drawing two dots on a piece of paper. Normally, moving from one dot to the other would take time, but if you fold the paper, the dots would align, allowing instant travel between them. This is how wormholes would theoretically work. However, the problem is that to keep the wormhole open long enough for someone to travel through it, it needs to be filled with exotic matter, a substance we don't yet understand. Most of the theories discussed here focus on traveling into the future. While traveling to the past seems more complicated, we can still look into the past by observing the stars. The light we see from distant stars and planets has traveled for thousands or even millions of years to reach Earth. In this sense, we are already witnessing history unfold in real time. So, for now, scientists continue to explore the mysteries of space and time. The dream of time travel remains alive, but we'll have to wait for the future to see if it becomes reality. Be sure to like this video, subscribe to the channel, and click the bell to stay updated on future discoveries.